Total internal reflection, the phenomena in which a ray of light traveling at an angle of incidence greater than the critical angle from denser to rarer medium is totally reflected back into the denser medium is called total internal reflection. Critical angle, the angle of incidence in the denser medium for which angle of refraction in the rare medium is 90 degree is called critical angle of the denser medium and it is denoted by C. According to the figure, when a ray of light AO passes from an optically denser medium to a rare medium at the interface XY, it is partially reflected back into the same medium along OB and partially refracted into the rarer medium along OC, as you can see in this diagram. If the angle of incidence is gradually increased, the angle of refraction R will also gradually increase and at a certain stage R becomes 90 degree. Now the refracted ray OC is bent so much away from the normal and it grazes the surface of separation of two media, as you can see in second portion of this diagram. If I is increased further, refraction is not possible and the incident ray is totally reflected into the same medium itself. This is called total internal reflection. If ND is the refractive index of denser medium, then from Snell's law, the refractive index of air with respect to denser medium is given by NAD, or we can write it Na upon Nd is equals to sin I upon sin R. We know that refractive index of air is equals to 1, so NAD is equals to 1 upon Nd is equals to sin I upon sin R. If R is equals to 90 degree, then I will be equals to C. So sin C upon sin 90 will be equals to 1 upon Nd. Nd is refractive index of denser medium. So we can write it sin C is equals to 1 upon Nd because we know that sin 90 degree is equals to 1. So our equation will be in terms of refractive index Nd is equals to 1 upon sin C. Necessary condition for total internal reflection. First one, light must travel from an optically denser to an optically rarer medium. Second one is, the angle of incidence in the denser medium must be greater than the critical angle for the two media.